Hi guys, I'm just doing video number 2 to actually show you how you calculate an F ratio, and this should make your understanding of partitioning of variance a bit more clear. So just another reminder, variance is the sum of the squared deviations from the mean for a particular sample. So it's the score minus the mean squared, and you sum that together. This is also called sum of squares, or SS, and if you divide that by the degrees of freedom, you get the mean sum of squares, MS. It's MS that is used in the calculation of F ratios, and SS that is used in the calculation of effect sizes. So F equals MS between groups over MS within groups. So I'll show you how to calculate the sum of squares, total sum of squares between and sum of squares within. So total sum of squares, which is the the squared difference of each participant's score from the grand mean, where the grand mean is the mean of the whole sample, can be divided into or partitioned into the sum of squares between groups, which is the squared difference of the participant's score from their group mean, and the sum of squares between groups is the squared difference of the participant's group mean from the grand mean, and the sum of squares within groups is the squared difference of the participant's score from their group mean. So together this equals total variance, because it's the difference between the participant's score from their group mean, the difference between the group mean from the grand mean, which together equals the difference between the participant's score and the grand mean. So sum of squares between groups, as I just said, is the difference between the group mean and the grand mean. Sum of squares within groups is the difference between the participant's score and the group mean, whereas sum of squares total is the difference between the participant's score and the grand mean. So this equals these two, which I'll show you on the next page. So this is the difference between the participant's score and the grand mean, so the total variance squared. And then within groups variance is the difference between the participant's score and their group mean. And between groups variance is the difference between the participant's group mean and the grand mean squared. So the within groups variance, the difference between the participant's score and their group mean, plus the between groups variance, the difference between the participant's group mean and their grand mean, equals the total variance. The within groups variance is considered a measure of background variation because all the participants within each group have experienced the same treatment effect. So if there was no individual differences or background variation, then there would be, all the scores within a group would be the same. But because there's individual differences and nuisance variables, the scores within a group are not the same. So this is within groups variance is considered a measure of background variation, whereas between groups variance may also be a measure of background variation as well, because every time you take, or nuisance variables, because every time you take a sample from a population, the means will differ. So the means between all three groups in the example that I will show you will differ, will always differ just because of random sampling variation. But if there is a treatment effect, the difference between the means should be greater than the difference within the group, than the within group variance, because the variance between the groups should be greater than the within group variance, because it's a treatment effect plus the background variation and nuisance variables, whereas this is just a measure of background variation. So hopefully, if you have a treatment effect, this will be greater than this, which is why F equals MS between groups over MS within groups, and you're hoping that the score will be greater than 1, which I will show you. So let's look at an example. We've got 3 different teaching methods, teaching method 1, 2 and 3, 4 participants in each group. Group 1 has a mean of 6, Group 2 has a mean of 7, Group 3 has a mean of 8. And we're hoping that, so these means might differ just due to random sampling variation, because every time you take a sample from a population, the means will differ. Or they might differ because of the effect of the teaching method. They might also differ because of the teaching methods, the difference in the teaching methods. So we want to know which is truer, whether they differ only due to random sampling variation or whether they also differ due to the effects of the teaching method. And so that's what ANOVAs will tell us. So the grand mean, or the total mean, the mean of all of the participants equals 7. N equals 4, the number of participants in each group. A equals 3, that's for factor A, or the number of groups is 3. In ANOVAs, IVs are called factors, as well as, so they're not, in the textbook, it's it says F equals MSA over MSW because A is for factor A, IVs are called factors. Total N equals 12, and Y stands for the group mean. So, to calculate the total variance, we take the difference between each participant score and the grand mean. The grand mean is 7. So, difference between the participant score squared, sum that together. So, for the first group, it's 3 minus 7 squared, 5 minus 7 squared, 7 minus 7 squared, 9 minus 7 squared. Plus, for the next group, 10 minus 7 squared, 7 minus 7 squared, 5 minus 7 squared, plus 6 minus 7 squared, plus 8 minus 7 squared, 6 minus 7 squared, plus 8 minus 7 squared, plus 10 minus 7 squared, to give you a total variance of 50. So for each group, it's just the difference between the participant score and the grand mean, the mean of all of the scores, squared and summed together. You do that for the whole sample to find the total variance. The variance between groups is the difference between the group mean and the grand mean squared for each participant. So for group mean, the mean for group 1 was 6. So for each participant, we do 6 minus 7 squared because 6 is the group mean, 7 is the grand mean. So you do that for each participant. You then do that again for the next group. Group 2, their mean was 7. So the group mean is 7 minus the grand mean, 7 is, you square that for each participant. There's 4 participants in each group, so you do it for each participant. Group 3, the mean was 8, so we do 8 minus the grand mean of 7 squared 4 times. So you get 4 times 6 minus 7 squared plus 4 times 7 minus 7 squared plus 4 times 8 minus 7 squared will equal 4 times 1 because the difference was 1 and 1 squared is 1, plus 4 times 0 because 7 minus 7 is 0, plus 4 times 1 because 4 minus 7 is negative 1 and negative 1 squared is 1. So we end up with 4 plus 0 plus 4, which equals 8. So the sum of squares between groups is 8. You guys don't need to know how to calculate this for this unit. You just got to have an understanding of what's going on. So for the sum of squares within groups is the difference between each participant score and their group mean squared. So this is a measure of the individual differences or background variation. So sum of squares within groups, you take each participant score. For group 1, the group mean was 6. So for each participant, 3 minus 6 squared plus 5 minus 6 squared plus 7 minus 6 squared plus 9 minus 6 squared. For group 2, the mean was 7. So for each participant, plus 10 minus 7 squared plus 7 minus 7 squared plus 5 minus 7 squared plus 6 minus 7 squared. The next group, the group mean was 8. So 8 minus 7 squared plus 6 minus 7 squared plus 8 minus 8 squared plus 10 minus 8 squared gives us a sum of squares within groups of 42. So sum of squares total equals sum of squares between groups plus sum of squared within groups. So the sum of squared total was 50. Sum of squared between groups was 8 and sum of squares within groups was 42. 50 equals 8 plus 42. So now we've got to calculate the degrees of freedom in order to be able to find the mean sum of squares, which is the sum of squares divided by the degrees of freedom. Again, the degrees of freedom total equals the degrees of freedom within groups plus the degrees of freedom between groups. So df total equals n minus 1, where n is the total number of cases. The df within groups equals n minus a, so the total number of cases minus the number of groups. And the df between groups equals a minus 1, the number of groups minus 1. Now, degrees of freedom is a mathematical concept. You don't have to bother yourself with why we have degrees of freedom. It's a concept that a lot of statisticians never fully understand because it's to do with mathematics, okay? So don't trouble yourself with it. And you don't need to know the degrees of freedom off by heart. You just got to be aware that this is the case. So degrees of freedom total n minus 1 equals degrees of freedom within groups plus degrees of freedom between groups, which is n minus a plus a minus 1, which equals n minus 1 equals n minus 1. So degrees of freedom total equals n minus 1. N is 12, because there's 12 participants in the group, minus 1 equals 11. So MS total equals SS total divided by the degrees of freedom total. SS total was 50, degrees of freedom total is 11, so 50 divided by 11 equals 4.45. So the total variance for the sample was 4.45. The degrees of freedom within groups equals n minus A. N was 12. There's 12 participants. A was 3 because there's 3 groups, so 12 minus 3 equals 9. So the mean sum of squares within groups equals the sum of squares within groups over the degrees of freedom within groups. The sum of squares within groups was 42. The degrees of freedom within groups is 9, so MS within groups equals 4.67. The degrees of freedom between groups equals A minus 1, where A is the number of groups in the IV. In factor A, there was 3 groups in factor A, so A minus 1 equals 2. Mean sum of squares between groups equals the sum of squares between groups over the degrees of freedom between groups. Sum of squares between groups was 8, degrees of freedom between groups was 2, so 8 divided by 2 equals 4. Now here comes the F ratio. F, we know, equals mean sum of squares between groups over the mean sum of squares within groups. This is a measure of background variation, and this is a measure of background variation and treatment effect. So you want this to be much greater than that, so you get an F that's substantially higher than 1. In our case, the mean sum of squares between groups is smaller than the mean sum of squares within groups, so we end up with an F ratio that's lower than F, so P would not be significant. This would have way more than 1 in 20 chance of occurring if there was no treatment effect and you just took a random sample from the population, 3 random samples from the population. This would have way more than 1 in 20 chance of occurring, or P, because P equals 0.05, which is 1 in 20 chance, and you want it to have less than 1 in 20 chance of occurring. So if you were to take 3 random samples, if you had a treatment, basically if there was less than 1 in 20 chance of you getting that F ratio score, if you took the samples randomly from the population, then you say this is unlikely to have occurred by chance, so it must be the treatment effect. So statistics is about probability. It's not fact, it's just probability. And that's the end.